Hello, Bob, I see that you're 21 years old. OK, so lots of room for improvement, right? What's one of the stupidest design decisions we made about a student? Right, it doesn't have anything in it, right? We're violating all of the fancy, nice little rules of thumb that we talked about earlier about encapsulation and data hiding and being able to validate data when you set it. So that was probably a cheat to just say everything is public and we're going to access it with the arrow notation only. So let's try now to improve upon this. But any questions on what we just did in this first example? Yeah? Oh, a prototype is just the return type, name, and arguments to a method, to a function that in C and Objective-C need to be stated at the very top of the file. So a C compiler, an Objective-C compiler, is kind of stupid in that you have to tell it in advance what functions exist. Otherwise, when it encounters the names of those functions, it won't know what to do. So because greet was defined at the bottom of my file, but it's used higher up in my file in main, I need to inform the compiler of it even higher up. Or what's a possible workaround to needing the prototype at all? Just move the function to the top of the file, which is a solution. It's not always possible, especially if you have circular references. But also, it's just nice, typically, I think, stylistically, to have main be the first thing in the file. So it jumps right out at you. All right, so let's go ahead and improve upon this one. Let me go ahead and define another command line tool, students2. Let me go ahead and hit enter, enter, and we're back at the point where we have a very simple starting point. And in version 2, let's at least introduce the notion of some setters or getters. Let's go ahead, actually, and pretend that I just followed all those steps. Let me go into lecture 4, students 2, and voila. We've just done what I said we would do. So here we have it in student.h. So this is almost identical. Notice that I did do this in advance, but I still have main.m, student.h, and student.m, and then all the other stuff, but I didn't touch any of the other stuff. We're only looking at 3 files at the moment. So in student.h, what's a little different? All right, so it looks like now I've done a few things that are different from before. One, inside of my student interface declaration, I still specify name and age, but for some reason I've prefixed them with underscores. Why might that be, if you have a hunch? Yeah. Yeah, so this is just a convention. When you anticipate variables being private, typically a convention in Objective-C, in Java, in other languages is to prefix them not with 2, but with 1 underscore, simply as a visual cue to you and any other developers working on the project that this is private. It's not something publicly accessible. It's just a useful trick. In the Windows world, you will very often use standard letters. Like in the Windows world, you'll say P for a variable name, a P foo, to indicate that foo is a pointer, and Microsoft has other similar conventions. Underscore typically connotes the idea of private. All right, so this is a little different, age and name. Now, what are these things called again? These 4 things collectively? Methods. So methods, and specifically, so instance methods. Instance methods meaning they can only be called once objects of type student exist, and the minus sign means exactly that. If they're instead class methods, it would be a plus. And if we actually looked at the code that someone wrote to implement an NS object in the .m and .h file for it, we would indeed see a plus for what method? Alloc, for the allocation method. All right, so these things we've seen before, albeit in the context of a slide, or we've seen things similar to this before. Age is the getter, set age is the setter. So whereas in the world of Java, it's common to say get foo and set foo, in the world of Objective-C, it's common to say foo and set foo. It's just a little cleaner, so you don't have to say the word get all over the place. So age is the getter, set age is the setter, and same deal here, name and set name. And notice that the data types are just different here for NS strings instead of ints, but realize they're returning pointers. So if you hated pointers in C, well, they are indeed back. This is not an abstraction we're going to be able to wave our hands at, as in Java. They're still there, but realize that it will be slightly less easy to crash your code as a result. All right, so that's it. And the only interesting thing to note, curly braces end up here. All of this stuff appears raw in the file, but before the @n sign. All right, and here's the .m file. So now we have the same thing before, at implementation and the import up top. So that means here comes our implementation, all of my methods. So how do I implement these? Syntax is pretty much the same. Just like in C, you copy and paste your prototypes and then remove the semicolon and start using curly braces. Same deal here. So minus int age is the getter. I'm just going to return underscore age. You shouldn't use this. Doesn't exist here. You simply mention the name of the variable, because when you're in the context of the object, the student object in question, underscore age refers to the instance variable. All right, same deal for name, return underscore name, and set age, we're going to do something very obvious. Underscore age gets age, and then down here we have name, underscore name gets name copy. That's actually kind of interesting. So we've not seen this yet. This is a message pass from a message called copy, the method, being passed to the object called name. And I say object because it's an object of what type? It's an NS string. Why, in this case, do I want to copy the name and then store the result in underscore name, as opposed to just do underscore name gets name, like I did up here? Yeah?
Is it because you're passing in like the address? So if, like, say later on somebody changed what's at that address to some other string,
Exactly.
you retain your original.
Exactly. So this is the danger in pointers, and in C also, is that if you're passing pointers around, if you just copy the pointer, you're literally copying the pointer to the same chunk of memory, which means if someone else in the program, some other method, changes that person's name, you don't have the original name. You have now the resulting change, which maybe is what you want, but more likely, if you've got an object called student, the whole idea of encapsulation is that you store your own state, and it should be pretty independent of anyone else's functionality. So in this case, we indeed do want to copy the name string by passing it that method, and what it effectively does is returns a new pointer to the new chunk of memory that has identical copy of DAVID or whatever the student's name actually is. So that's the one distinction there. All right, any questions syntactically? All right, so now if we go back up to main.m, in this case, things don't change all that much in terms of allocation, but notice that the getter and setter are now being used. So the setters are being used here. Rather than just use the arrow notation, which you'll generally not use in Objective-C for reasons of encapsulation, now we're passing Alice the message setAge:20 to set her age. The name is being passed as well there, and then we're greeting her. So we'll see how the greet method, greet function has changed. Bob is the same deal. And then if we scroll down here, notice that it's almost the same code in the nslog statement, but now I just say sname and sage instead of actually using the arrow notation. So in short, even though the syntax is kind of different, like none of these ideas are yet new, other than some of the jargon that we've been using versus PHP and even C. Any questions? All right, so let's start to clean this up. One of the most powerful things about Objective-C is that we can actually eliminate all of this stuff. Like this, we only have 4. But recall the story that we started with. If you have all these getters and setters, suppose we do add email, suppose we do add dormitory and phone number and the like. My God, we're going to have a dozen or more getters and setters in this file. And thankfully, and one thing Java does not have to the same extent, but that Objective-C does, is you can automatically create all of these getters and setters for you, even in a more effective way than PHP's __ get and set. So let me go ahead and open up version 3 of this here. And in version 3, notice what I've done in my .h file. So has anything changed? Little sanity check. Has anything changed in my interface declaration for my instance variables versus the last example? Someone go on the record with a yes or no. OK, good. So nothing's changed. So that's exactly the same. So this stuff is also the same. This stuff now is new. So notice we have at property. So here in answer to Kevin's question about the @ sign, again, it's being used here for a new piece of syntax, at property. We have some kind of comma-separated list of things inside of parentheses. Then we have, OK, now it's familiar, int age, NSString, star name. So let's come back to what this means in just a moment. And let's look instead at the .m file. And what we have in the .m file is this. So same deal as before, where I do have these getters or setters, but the advantage now is that we're one step closer to being able to do this automatically. So notice here we've done a few things. At property, int age, at property, NSString name. What this is going to allow us to do next is, one, automatically create all of those getters and setters. We'll soon be able to delete all of those. And it will also let us invoke these things using a slightly more friendly dot notation. So you might recall from Java and other languages, instead of using arrow notation all over the place, you can do something like s.foo. And one of the things you get with Objective-C properties is that rather than have to say something annoying like this all over the place, open bracket s space foo, close brace, which recall we did in the greet method, right? Instead of saying something like this, s arrow foo, we had to say open bracket s space foo. It just becomes a mess. It's really hard to read, certainly in longer chunks of code. Soon we can start saying s.foo. So the mere fact that I've still implemented in this version 3 all of my getters and setters, but I've told the compiler to make me properties called age and name, what this is going to do for me is ensure that I can actually start using that dot notation already. So it's just syntactic sugar, but this tends to be a nice thing, especially when you start writing the same thing again and again. And we'll come back to this in just a moment. So that's going to allow me to use, in short, a little notation like this down here. Alice.age gets 20. Alice.name gets at quote unquote Alice. This is in contrast to what? A moment ago, these calls looked like what instead? This was Alice set age 20. And this other one was Alice set name colon at Alice. So what has the mere use of the at property keyword done for us? Well, one, it's literally let us rewrite these two lines as these two lines. And they're arguably cleaner, right? They do the same thing. How did it do that? Well, this is mostly by way of convention. The reason that you should, even though you don't strictly have to, call your getters and setters foo and set foo with set capital F as a convention is when you start using the at property keyword, Objective-C, specifically the compiler, is going to assume that when you say Alice.age equals something, it's going to automatically call the setAge method on that object for you with the value that's on the right-hand side. So it's just, again, syntactic sugar. It's doing the exact same thing we could have done 5 minutes ago, but frankly, it's getting a little more familiar, a little friendlier, and just more readable ultimately. And similarly, if we now look at the greet method down here, notice this too. Come on, this is more readable than open bracket, s space, and so forth. And that's what we've gotten now with properties. But we can take this one step further. If I now go ahead and open up version 4, and again, all these files are available online if you'd like to tinker at some point. Now let me go into student.h, which looks a little different here. Notice that I've gotten rid of a few things. This is version 4 now. What's disappeared from this file? It's definitely different now.
All the getters and setters.
All the getters and setters have sort of somehow disappeared, and all of the instance variables have disappeared on me. So this does not seem good. This seems like a step backwards. But let me go to the M file, and oh my God, I can literally rip out all of the code I just wrote in Objective-C and simply say, synthesize me a property called age and back it with an instance variable called _age. I could call it anything I want, but this one-liner here is saying synthesize a property and make sure you use a variable called _age to store that property. The property is defined in the other file, declared in the other file, and we'll look at that again in just a second. But what this means more specifically is create automatically for me a getter and create for me automatically a setter without me writing a single line of code besides this one here. So this is a huge leap forward, frankly, because what we can also do now is also enforce a few constraints. So now we can tease apart this comma-separated lists. So at property, int age, at property, NSString star name, did all that. But what about these getters and setters that are going to be synthesized, that is automatically written for me by the compiler? They can adhere to a few attributes. So this comma-separated list, and the order doesn't matter. I tend to be anal and just alphabetize them. But assign means when you create the setter, go ahead and literally do _age equals age. So assign means literally implement my setter in a way that uses assignment, just like this. By contrast, and you can kind of guess now, when you say copy instead of assign, what kind of setter gets automatically created for you? _name gets, Yeah, so the name argument that was presumably passed in to the setter, and then pass it the copy message. Where does the copy message, or where does the copy method come from? Where was it defined? So in the NSString class. In the NSString class. It's an instance method that you get for free. So that's the distinction there. So assign, this is OK. I don't need to copy the age per se. Why? Right, so it's a primitive you don't need to worry about. And specifically, I am copying it. But when you copy